Shri Rajlaxmi Prakashan published. A textbook on fundamentals of agronomy 1. Authors: Dr. D. N. Jagtap, Dr. P. B. Pawar, Dr. U. V. Mahadkar. Chapter 6. Effect of plant population on growth and yield, planting geometry that is solid, paired and skipped row planting. Crop stand establishment. Good crop establishment is one of the most important features in better crop production. The better crop establishment is in turn expressed as optimum plant population in fields. Number of plants per unit area in the cropped field is called as plant population. Optimum plant population. It is the number of plants required to produce maximum output or biomass per unit area. Any increase beyond this stage results in either no increase or reduction in biomass. Importance of plant population. Yield of any crop depends on final plant population. The plant population depends on germination percentage and survival rate in the field. Under rain-fed conditions, high plant population will deplete the soil moisture before maturity, whereas low plant population will leave the soil moisture unutilized. When soil moisture and nutrients are not limited, high plant population is necessary to utilize the other growth factors like solar radiation efficiently. Under low plant population, individual plant yield will be more due to wide spacing. Under high plant population, individual plant yield will be low due to narrow spacing leading to competition between plants. Yield per plant decreases gradually as plant population per unit area is increased, but yield per unit area increases up to certain level of population. That level of plant population is called as optimum population. So, to get maximum yield per unit area, optimum plant population is necessary. So the optimum plant population for each crop should be identified. Factors affecting plant population. Point A. Genetic factors. Number 1. Size of the plant. The volume occupied by the plant at the time of flowering decides the spacing of the crop. Plants of red gram, cotton, sugarcane etc. occupy larger volume of space in the field compared to rice and wheat. Even the varieties of the same crop differ in size of the plant. Number 2. Elasticity of the plant. Variation in size of the plant between minimum size of the plant that can produce some economic yield to the maximum size of the plant that can reach under unlimited space and resources is the elasticity of the plant. The optimum plant population range is high in indeterminate plants. Example: red gram 55,000 to 1,33,000 plants hectare. The elasticity is due to tillering and branching habit of the plants. For determinate plants like pearl millet, sorghum elasticity range is less. For indeterminate plants like cotton and red gram, more branches will be produced by the crop. Number 3. Foraging area or soil cover. Crop should cover the soil as early as possible so as to intercept maximum sunlight. Higher the intercepted radiation, more will be the dry matter produced. Close-spaced crops intercept more solar radiation than wide-spaced crops. Number 4. Dry matter partitioning. Dry matter production is related to amount of solar radiation intercepted by the canopy, which depends on plant density. As the plant density increases, the canopy expands more rapidly, more radiation is intercepted and more dry matter is produced. Number 5. Crop and variety. Depending on the crops and varieties, the plant population varies. Crop rice. Short duration 6,66,666 plants hectare, 15 centimeters by 10 centimeters. Medium duration 5 lakhs plants hectare, 20 centimeters by 10 centimeters. Long duration 3,33,000 plants hectare, 20 centimeters by 15 centimeters. Crop cotton. Medium duration 55,555 plants hectare, 60 centimeters by 30 centimeters. Long duration, 44,444 plants hectare, 75 centimeters by 30 centimeters. Hybrids duration, 18,518 plants hectare, 120 centimeters by 45 centimeters. Crop match. Varieties duration, 83,333 plants hectare, 60 by 20 centimeters. Hybrids duration, 47,620 plants hectare, 60 by 35 centimeters. Point B. Environmental factors. Number 1. Time of sowing. The crop is subjected to various weather conditions when sown at different periods. Among weather factors, day length and temperature influence much on the plant population. As low temperature retards growth, high plant population is required to cover the soil. Number 2. Rainfall irrigation. Plant population has to be less under rain-fed than irrigated condition. Under more plant densities, more water is lost through transpiration. Under adequate rainfall irrigation, high plant population is recommended. Number 3. Fertilizer application. Higher plant population is necessary to fully utilize higher level of nutrients in the soil to realize higher yield. Nutrient uptake increases at optimum plant population. High population under low fertility soils leads to nutrient deficiency symptoms leading low yield. Number 4. Seed rate. Quantity of seed sown unit area, viability, and establishment rate decides the plant population. Under broadcasting, the seed rate is higher when compared with line sowing transplanting. Example: rice. Direct sowing 100 kilograms per hectare, line sowing 60 kilograms per hectare, transplanting 40 kilograms per hectare. Plant geometry. The arrangement of the plants in different rows and columns in an area to utilize the natural resources efficiently is called crop geometry. It is otherwise area occupied by a single plant. Example: rice 20 centimeters by 15 centimeters. This is very essential to utilize the resources like light, water, nutrient and space. Different geometries are available for crop production. Different crop geometries are available for crop production. Number 1. Random plant geometry. Random plant geometry results due to broadcasting method of sowing and no equal space is maintained. Resources are either underutilized or overexploited. Number 2. Square plant geometry. The plants are sown at equal distances on either side. Mostly perennial crops, tree crops follow square method of cultivation. Example: coconut 7.5 by 7.5 meter, banana 1.8 by 1.8 meter. But due to scientific invention, the square geometry concept is expanded to close-spaced field crops like rice too. Advantages: light is uniformly available. Movement of wind is not blocked. Mechanization can be possible. Number 3. Rectangular method of sowing. There are rows and columns. The row spacing are wider than the spacing between plants. The different types exist in rectangular method are: Point A. Solid row. Each row will have no proper spacing between the plants. This is followed only for annual crops which have tillering pattern. There is definite row arrangement but no column arrangement. Example: wheat. Point B. Paired row arrangement. It is also a rectangular arrangement. A crop requires 60 centimeters by 30 centimeters spacing, and if paired row is to be adopted, the spacing is altered to 90 centimeters instead of 60 centimeters in order to accommodate an intercrop. The base population is kept constant. Point C. Skip row. A row of planting is skipped and hence there is a reduction in population. This reduction is compensated by planting an intercrop practiced in rain-fed or dryland agriculture. Point D. Triangular method of planting. It is recommended for wide-spaced crops like coconut, mango, etc. The number of plants per unit area is more in this system. Plant density is the number of plants per unit area in a cropped field. It indicates the size of the area available for individual plant. Crop geometry is the pattern of distribution of plant over the ground or the shape of the area available to the individual plant in a crop field. Importance. Yield of a crop depends on the final plant density. The density depends on the germination percentage and the survival rate in the field. Establishment of required plant density is essential to get maximum yield. For example, when a crop is raised on stored soil moisture under rain-fed conditions, high density will deplete moisture before crop maturity, whereas low density will leave moisture unutilized. Hence, optimum density will lead to effective utilization of soil moisture, nutrients, sunlight, etc. When soil moisture and nutrients are not limited, higher density is necessary to utilize other growth factors, solar radiation, efficiency. When maximum yield per plant. On the contrary, when the density is more, individual plant gets narrow space leading to competition for growth factors between plants resulting in reduction of yield per plant. Yield per plant decreases gradually as plant density per unit area is increased as shown in the. However, the yield per unit area is increased up to a certain level of plant density due to utilization of growth factors. Maximum yield per unit area can, therefore, be obtained when the plant density is optimum. Plant density and yield. Biological yield increases with increases in plant density up to a point and reaches a plateau with further increase in density, thus no additional biological yield can be obtained. On the other hand, the economic yield increases with increase in plant density up to a point and subsequently decreases with increased in density. Plant density and growth. Plant height increase with increase in plant density due to competition for light. Dense plant stands leads to reduction in leaf thickness and alters leaf orientation. Dry matter production per unit area increase with increase in plant density up to a limit, as in biological yield. Factors affecting plant density. Optimum plant density is necessary to obtain maximum yield. Optimum plant density depends on size of the plant, elasticity, foraging area, nature of the plant, capacity to reach optimum leaf area at an early date and seed rate used. The factors affecting plant density are grouped into two as A. Genetic and B. Environment factors. Point A. Genetic factors, plant or internal factors. Number 1. Size of plant. The volume occupied by the plant at the time of flowering decides the spacing of the crop. Plants of red gram, cotton, sugarcane, etc. occupy larger volume of space in the field compared to rice, wheat, ragi, etc. Even the varieties of the same crop differ in size of plant. Number 2. Elasticity of the plant. Variation in size or plant between the minimum size of the plant that can produce some economic yield to the maximum size of the plant that can reach under unlimited space and resources is the elasticity of the plant. The optimum plant density range is high in indeterminate plants. For example, in indeterminate red gram varieties, the optimum plant density ranges from 55 to 133,000 plants hectare. The elasticity of plants is due to branching or tillering. For determinate plants like maize, sorghum, etc., the elasticity is less and hence the optimum plant density range is small. The removal of auxiliary buds is done to get uniform and early maturity in cluster. Number 3. Foraging area or soil cover. The crop should cover the soil as early as possible so as to intercept maximum sunlight. More interception of solar radiation leads to more dry matter production. Closely spaced plants intercept more radiation than widely spaced plants. Area of root spread also decides the density. Number 4. Dry matter partitioning. Dry matter production is related to the amount of solar radiation intercepted by the canopy, which depends on the plant density. As the plant density increases, the canopy expands more rapidly, more radiation is intercepted and more dry matter is produced. Point B. Environmental factors, management factors. The primary management factor affecting the plant density of any crop varieties is the method of stand establishment sowings like transplanting or broadcasting. For transplanting direct drilling, the genetic factors are the deciding factors on the number of plants per unit area. For broadcasting, the factors are: Number 1. Time of sowing. The crop is subjected to different weather conditions when sown at different periods. Among the weather factors, the most important factors that influence optimum plant density are day length and temperature. Photosensitive varieties respond to day length, resulting in change in size of the plant. As low temperature retards the growth, higher density is established for quicker ground cover. Number 2. Rainfall irrigation. Plant density has to be less under rain-fed than irrigated conditions. Under higher plant densities, more water is lost through transpiration. Under adequate irrigation or under evenly distributed rainfall conditions, higher plant density is recommended. Number 3. Fertilizer application. Higher plant density is necessary to fully utilize higher level of nutrients in the soil to realize higher yield. Nutrient uptake increases with increase in plant density. Higher density under low fertility conditions leads to development of nutrient deficiency symptoms. For example, rice does not respond to plant density without nitrogen application. Number 4. Seed rate. Quantity of seed sown unit area, viability, and establishment rate decides the plant density. Crop geometry. Crop geometry refers to the shape of the space available for individual plants. It influences crop yield through its influence on light interception, rooting pattern, and moisture extraction pattern. Crop geometry is altered by changing inter- and intra-row spacing, planting pattern. Wider spaced crops have advantage under this geometry. Plants which requires no restriction in all directions are given square geometry. Usually perennial vegetations like trees, shrubs are under this arrangement. Number 1. Square planting. Square arrangements of plants will be more efficient in the utilization of light, water and nutrients available to the individual plants than in a rectangular arrangement. Number 2. Rectangular planting. Sowing the crop with seed drill, wider interrow and closer intrarow and closer intrarow spacing leads to rectangularity. Rectangular arrangement facilitates easy intercultivation. Rectangular planting mainly suits annual crops, crops with closer spacing etc. The wider section, row, is given for irrigation, intercultural operation etc. It is an arrangement to restrict the endless growth habit in order to switch over from vegetation to the productive phase. This method accommodates high-density planting. It can facilitate intercropping also. Number 3. Triangular planting. It is a method to accommodate plant density under perennial tree crops. Number 4. Miscellaneous planting. In rice and ragi, transplanting is done either in rows or at random. Skipping of every alternate row is known as skip row planting. When one row is skipped, the density is adjusted by decreasing inter-row spacing. When the inter-row spacing is reduced between two rows and spacing between two such pair are increased, then it is known as paired row planting. It is generally done to introduce an intercrop. Intercultivation. Cultivation practices taken up after sowing of crop is called intercultivation. It is otherwise called as after operation. There are three important after cultivation processes, that is, thinning and gap filling, weeding and hoeing and earthing up. Number 1. Thinning and gap filling. The objective of thinning and gap filling process is to maintain optimum plant population. Thinning is the removal of excess plants leaving healthy seedlings. Gap filling is done to fill the gaps by sowing of seeds or transplanting of seedlings in gap where early sown seed had not germinated. It is a simultaneous process. Normally, these are practiced a week after sowing to a maximum of 15 days. In dryland agriculture, gap filling is done first. Seeds are dibbled after 7 days of sowing. Thinning is done after gap filling in order to avoid drought. It is a management strategy to remove a portion of plant population to mitigate stress is referred to as mid-season correction. Number 2. Weeding and hoeing. Weeding is removal of unwanted plants. Weeding and hoeing is a simultaneous operation. Hoeing is disturbing the top soil by small hand tools and helps in aerating the soil. Number 3. Earthing up. It is a dislocation of soil from one side of a ridge and to be placed nearer the cropped side. It is carried out in wide-spaced and deep-rooted crops. It is done around 6 to 8 weeks after sowing planting in sugarcane, tapioca, banana, etc. Number 4. Other intercultivation practices. Harrowing, stirring or scraping the surface soil in inter- and intra-row spacing of the crop using tools or implements. Roguing, removal of plants of a variety admixed with other variety of same crop. Example. In IR50 rice field, the other rice varieties are rogue. It is practiced in seed production to maintain purity. Topping, removal of terminal buds. It is done to stimulate auxiliary growth. Practiced in cotton and tobacco. Propping, provision of support to the crop is called propping. Practiced in sugarcane commonly. It is done to prevent lodging of the crop. Cane stalks from adjacent rows are brought together and tied with their own trash and old leaves. Detrashing, removing of older leaves from the sugarcane crop. Desuckering, removal of axillary buds and branches which are considered non-essential for crop production and which removes plant nutrients considerably are called suckers. Example. Tobacco.
We politely request, please like, share and subscribe our channel Shri Rajlaxmi Publication.